Welcome, everybody. Welcome to the October meeting of the Ottawa Centre RASC. Glad you could all come out tonight. And your trip here will not be in vain because we have an awesome presentation for you tonight. We've got, oops, sorry, that's twice I've done that. We've got a number of really interesting talks, and we have got some amazing observations. So I guess the summer's been good to us. People have gotten out with their cameras and taken some very, very neat imagery, and which we're going to share with you tonight. So yeah, it's going to be a good program. It's going to be a busy one. We've got a lot of slides again, but we'll try not to run too much overtime or anything. All right, oh yes, for our first one, members in the news. I'm gonna boot right along here. So for those of you that bought your calendar last year, you'll have seen a lot of this image. It's the current image for October, a gorgeous lunar shot by our own Rolf Meyer, who I don't think is here tonight. Rolf, are you here? No? Okay. Good job anyway, Rolf. All right. And something new we're going to do a little bit here to acknowledge new memberships, and so we want to welcome these following members to the club. Hopefully, some or most of you are here, and welcome. I think if you haven't seen many presentations yet, I think you're going to enjoy what you see tonight. So welcome, and hope you enjoy your membership at with the RASC. All right. Yeah. Sure. Now I'm going to put on my Gary Boyle hat, because Gary can't be with us tonight. He's doing other things there, so president for a night, right? Okay. All right, Ottawa skies. I know Gary probably had a lot more to say about these than I will, because these are all his slides. But just to give you a bit of a summary, happening in the evening sky right now, we have just at sunset we have Venus and Saturn visible. If you've got a low enough horizon and clear enough skies, which we were really blessed with last week. We had an excellent run last week. So keep your eyes on those. That's a very nice pair, very prominent in the morning sky, even when the dawn light starts to come up. And if you've got really sharp eyes or a telescope, check out Pluto while you're in the area. All right, next one, please. Yes, what do we got here? Yes, the summer triangle. We're showing this for a number of reasons. First of all, it's one of the nicest parts of the northern sky that you could ever want. I mean, with binoculars or just even visually, but certainly with a telescope, scanning through that area is very, very rich. As we've mentioned, you've seen a number of good images, especially during the summer. And we are rapidly losing the summer triangle because we are rapidly away from summer. But yeah, it's still visible. It's still quite nice. Still quite nicely placed overhead, fairly early in the evening there, and still a beautiful opportunity to do some viewing or some imaging if you're into that. The other reason that we are showing this slide, thank you, Chris, is the next image is of the Ring Nebula, but it's Ring Nebula Plus. So. Without further ado, we just wanted to show you where that was. There's the Ring Nebula itself. Most of you have probably seen pictures of that, but there's also a supernova that happened in that nearby galaxy to the Ring Nebula that often astro imagers try to image if they're even aware of it. A nice spiral galaxy, fairly distant, but a supernova was discovered in that galaxy just recently. So very easy to find. I don't have any current numbers on it in terms of its visibility. I think it was fairly recent. Glenn, are you aware of any of that? Have you heard anything?
In terms of the magnitude.
No, eh? Okay. Anyway, so it is in the vicinity. The M57 certainly is very easy to find, and which makes that galaxy very easy to find too. M57 is a very small planetary. It's really not much bigger than the size of Jupiter. So if you can find that, you can probably find the galaxy. But I suspect you would need a fairly good scope or a camera to pick it up. All right, next one. Jupiter and Mars. Oh yes, if you're a night owl with morning tendencies, if that even makes sense, the morning sky presents two other planets. We had Venus and Saturn in the evening sky. We have Mars and Jupiter in the morning sky, in the very early morning sky. For your reference, those are the constellations that they are currently gracing. Excuse me, Jupiter up in Gemini and Mars just off to the side of Leo. Another interesting sidebar, currently, again, for those of you with telescopes and no jobs to go to in the morning, yeah, this is an early morning out. This thing's got to get high enough. But Comet Ison is currently just above Mars there, so very close to the vicinity there. If you can certainly download coordinates or an ephemeris from the internet. And yeah, oh, there we go. I didn't even see you put that up. That's a new addition. Good job. Anyway, there's the path of it there. So if you want to get a preliminary look at Comet Ison, I think it's still kicking down around, I think I heard like 13th or...
Is it on there? Can you read that fine print?
Whoops. There, that's again with the mic. No, those are the... Is it at 10? Somebody said 10? Oh, wow. Okay. So that makes it a whole lot easier to see. But yeah, there you can see I don't have the pointer here, right?
Right there.
Oh, there it is. Thank you. So there you can see Mars. It actually looks like it may have come close to occulting Mars there, but no, these are the
dates.
These are the dates. Yeah. So there we're looking at October the 1st to the 13th there. So we're kind of in the middle of that. In fact, what have we got tonight? The 4th there. So yeah, currently right around there. There. So easy to find, certainly easy to find Mars, and again, not very far from Mars if you're that way inclined. And if it's at 10th magnitude, a good pair of larger binoculars might be able to get it for you as well if the sky conditions are amenable to that.
Is it actually physically passing fairly close to Mars as well?
Yes. Actually, the NASA's, well, the plan was, I don't know if they're still doing this, the plan was to actually target the imaging cameras on the rovers to try to see if they could get it, because it's actually flying relatively close to Mars. But it seems as though the U.S. government is like shut down. I'm not kidding you. Go on many NASA websites right now. You know what you get? Sorry, gone fishing, right? It's true. Yeah, that's a strange thing anyway. So I'm assuming they've opened the piggy bank a little bit to let the guys at least drive the rovers or make sure they don't go over a cliff or something, because yeah, you don't really want to lose a $2 billion spacecraft. You don't get many of those to play with. So anyway. If the funding is there and if they're allowed to even do it, the current plan is at some time very close to now. Actually, the rovers are supposed to start trying to image it from Mars, so it'll be interesting to see if they can pull that off.
Are those times in universal time?
I would assume so. I did not. I didn't put the chart together, but yes.
Well, this is 1 tick per day, right?
It's just 1 tick per day. Yeah. So yeah.
Well, I guess that close. The comet from Mars would probably be a naked eye object, I expect, during their closest approach to Mars.
It could well be. I mean, if it's 10th magnitude from here, it's, yeah. It'll be interesting to see. Certainly if they do manage to snap some pictures with the rovers there, I'm sure they will be posted on APOD and Space Weather and similar such sites. So keep an eye open for that, and we'll see if we get any satisfaction out of that. All right, and that is, oh yeah, there, yes, that's the comet there. That's Ison there. This was taken relatively recently. I remember this shot actually. And there's Mars there, obviously overexposed so that they could image the comet, but relatively close. It's already sprouting a pronounced tail there, or a little bit of a tail anyway. That's certainly enough to notice. So yeah, if you have the opportunity, give it a look there before it makes its glorious plunge in towards the sun.
I guess the last point, this affords an opportunity to compare the physical size of a comet to a planet, because if they're at a fairly similar distance from us, then their apparent size reflects their actual true size. So
of the coma is certainly, yeah, not the nucleus.
Will be a tiny little dot in a telescope, but the comet will fill a reasonable, or even more than the field of view at the same magnification.
Yeah, well, even there it already looks, because Mars is so overblown, it already looks like the comet is subtending a greater angle than Mars itself. So.
Oh, by leaps and bounds.
Yeah.
The size of Mars at that image scale would be probably smaller than most of the stars.
Most of the stars, yeah. It's just it's so bright. So anyway, keep an eye for that.
Do you have any degrees of separation
Oh.
between the comet and Mars?
If I had to take a guess, I'd say about 2 degrees.
What's the separation between those two and Leo?
Yeah, it's probably something about 2 degrees.
Yeah, it's not much, certainly not much more than that. So maybe like 3, 4, maybe 5 times the diameter of the full moon. somewhere in that ballpark there. So yeah, certainly. And again, if it is 10th magnitude, just scan with your binoculars just above Mars there, and if you're under a good sky, you might be able to just pick it out. Good stuff. All right. Zodiacal light. That's a nice shot from Hawaii, I assume there. But yeah, I'm not sure what Gary was going to say to that. It's just an intrinsically nice shot of the zodiacal light. First 2 weeks in October. A good time of the year to see them actually see it in the fall. And his customary closing slides there. So October the 4th, we have the new moon, which is today. And guess what? It's cloudy with the new moon. Isn't that nice? I mean, yeah. Yeah. Remember last week when it was like really clear, but the moon was like really up for most of the early part of the evening? Yeah. Oh yes, the universe likes to play games with us. Anyway, so we have first quarter on the 11th, and be very, very quiet. Hunter's moon on the 18th of October.
That was good, Bob.
Thank you. Wasquey Gary. He put it in there. I didn't. I just couldn't resist. All right, and last quarter on October the 26th. No blue moons this month. All right, and hopefully Gary will be back to see you next month and talk about the Ottawa skies. All right, Mr. Wagstaff. Oh, I'll send those to Gary. Mr. Wagstaff, where are you? There you are. I know you're here. Now, all you guys listen really carefully. If you own a green laser pointer, he's the man, and he's gonna be watching. Go for it.
There'll be a test at the end.
As there should be. Actually.
Yeah. Good evening, everyone. I had planned to do this talk quite a while ago, and it just kind of got lost in the shuffle. Really, it got resurrected due to this photograph, actually. It was, you can see the green line there. This is at the Diefenbunker, and it was brought to my attention that maybe we needed to go over what the policy of the RASC is with respect to green laser pointers. But as well, I thought it was a good opportunity to clarify for people what the legislative situation is with respect to them right now, and maybe touch on the technology a little bit, try and clarify things. So very useful devices. I use a couple of them myself. I was out Wednesday night, lucky me, I'm retired. So got out to a very dark sky site with a friend of mine. We tend to observe as partners. He's very good at reading charts and star hopping. I have what seems to be very, very good low light vision. So between the two of us, he'll typically look up in the charts and he'll point at a spot in the sky and say, look there. And I'll get my binoculars out and I'll look for the spot and I'll go, yes, I see it. And then he'll get his binoculars, which are on a stand, a Paragon mount, and he'll say, where is it? And I'll illuminate it while I'm looking through my handheld binoculars. I'll illuminate the object. He'll find it in his binoculars on the mount. And then what is it? He'll go, good, I can't see it, but I've got your spot. So then I go over to the Paragon mount. He goes to the Daub, and he says, okay, show me where it is. I'll look through and I'll go, it's right there, and illuminate the object. He'll find it in the scope, and we're off. So we were hunting the helix the other night, and it worked very, very well. I could clearly see it with handheld 10-power binoculars. He couldn't see it until he had the Daub on it. But yeah, it works very, very well. One little observation while we were doing that, we have a couple of different laser pointers. One is a 5 milliwatt, another is a 30. The 30 was way too much for a dark site. I was finding I was losing my night vision just because of the amount of glare from the 30. Simply the beam in proximity to where I was looking, it would usually take me a good 5-10 seconds before I could start to see things again. afterwards. So, you know, you can definitely have too big a one. So let's move on a little bit here. Next, please. So why the talk? Primarily, there's been a rising number of aircraft illumination incidents where people are flashing aircraft. It's not just an aircraft problem. It's a problem for sporting events. There have been lots of incidents now where people from the opposing team's fan base will be flashing players in the eye while games are going on. There was an incident a little while ago where a motocross rider, the brother of one rider, was in the stands and was flashing other riders in the eyes to try and give his brother an advantage. People are being charged left, right, and center with offenses to do with this. So aircraft illumination is just one issue. We consider it to be particularly serious because potentially it endangers the lives of not just one person, bad enough, but it could be a plane load of people. So it's a big issue, and there's a lot of concern. Many countries are legislating against GLPs or severely limiting the power of what's available to the public as a result of these incidents. And we're very concerned that they may be regulated more heavily, and we may lose a very useful tool for education and for outreach as astronomers. RASC has published a position statement and has a policy with respect to how to use them, and I think our membership need to be familiar with that. Next, please. Okay, so just talking a little bit about what they are. You know, I tend to work in engineering when I'm working, which isn't anymore, but I'm technically inclined, so I look at them and I go, what are these?
That's twice, eh?
Yes, I enjoy this very much. Yeah. Okay, so basically they're a collimated coherent light beam. What does that mean? Collimated, the light has been all directed into a nice parallel beam. It's also coherent. It's all the same wavelength, give or take. It's pretty close. And all of the photons are moving pretty much in the same direction. So you don't get a lot of scattering when the beam exits from the device rather than a normal flashlight spreads and scatters all over the place. Because all of the photons are moving pretty much in the same direction, they tend to stay in that beam. And so you get a narrow beam and it stays narrow a long way out. Green in particular, you've all seen red laser pointers. There's a whole spectrum of them out there. You can get blues, you can get purples, you can any color you choose, you can get lasers for these days. Well, effectively anyway. Our eyes are very sensitive to green, and so we are able to see the beam from a green laser much more easily than we can the others. As it happens, combined with that, some of the colors like blue and green tend to scatter off of not just dust in the air, but also they scatter due to an effect called Rayleigh scattering off of the molecules of the air itself. And so as a result, with some colors like blues and greens, when you shine them, you can see the beam itself. That's not just dust you're seeing. Even in clean air, you can still see them. That's actually scattering off of the light or off of the air molecules themselves. That carries on for a certain distance. You've probably seen they look like they go on for a certain distance and then they disappear. That's a point at which the Rayleigh scattering falls to the point where you're not able to see the backscatter from it, but nevertheless they carry on. They don't end there. They carry on effectively to infinity. Go a long way, and they don't diverge very quickly either. Now, these devices are very useful for pointing. We use them all the time. You've probably all seen them, as I was describing, and you can get them in a range of power levels. Next, please. Yep.
I have a question.
Sure.
If you were to point a laser in space,
Yes?
from the side, you wouldn't be able to see it then, can you?
Not unless it reflected off of something. No, it's not visible in vacuum.
Which means all this science fiction where you see a laser going across, you really can't see that.
No, you can't. No.
I never realized that before.
Yeah, unless you were in a field of dust or something like that was going
But
to
in
scatter
space,
a
in a
bit.
vacuum, you won't.
No, you wouldn't see it.
Well, you know, there are interstellar dust clouds that you may run across, but no, generally. Yeah, but generally not, no. You're not going to see it at all. So yeah, that's kind of a fallacy. It's another one of these things that you get from movies, TV. Not really factual.
I've got a question. In regards to the light distance of these pointers, isn't there a limited distance in regards to a standoff object?
I'm not quite sure what you mean by the.
Talking about an aircraft flying overhead?
Yeah, I'll touch on that a little later if we could hold that for a moment. I've got a slide that addresses that. Okay, good. So next slide, please. They're classified under the regulatory agencies into a number of classes. The classes we most often see are class 3 lasers, but just to give you an example, there are class 1, 2, 3, and 4, and class 3 is divided into 2 subparts as well. Class 1 lasers are the kind of thing you see in like a DVD player or that sort of thing. They're low wattage. They're deemed to not be a hazard really, although there are some wavelengths that I suppose if you were to get close to one, you might be able to injure yourself, but it's pretty remote, okay? Class 2s are low power, and they're in the visible band, so the light that you see from them, in addition to being low power, is visible, and people tend to look away, like you blink or whatever if you get illuminated by them. So again, they're not deemed to be a real hazard at all. Once you get into class 3, you get into medium power, and most of the laser pointers that you're going to see, reds or whatever, fall into this category. Class 3A is normal consumer stuff. It goes up to 5 milliwatt, quite adequate for our purposes, in my opinion, although I have one bigger than that. But there's quite a move afoot these days to regulate that, except for professionals who actually need higher power, that class 3As will be the most that you'll be able to get. Class 3B, start from where 3As leave off, and they go up to a half watt power, which is a very, very powerful laser pointer. That's on the verge of being able to burn things with it. Incredibly bright. There are a number of different manufacturers who make these available on the web. You can get your hands on them one way or another. And then class 4 are high power stuff, for like laser cutters for cutting balls or for other materials where you see laser cut objects. For some forms of telecommunications, they use very high power lasers, that sort of thing. Okay, so it gives you a rough idea of what you're looking at in here. There are actually some manufacturers out there who manufacture handheld lasers, laser pointers effectively, that are capable of burning, like you can burst balloons across the room with them, that sort of thing. These things are deadly to have in the wrong hands. They're very dangerous, and it just doesn't make sense to have people casually keeping them around. Anyway.
I've actually seen balloons popped, Bill, with 100 milliwatt lasers.
Mm-hmm.
Yeah, at like 10 feet, 12 feet.
Okay,
Yeah.
okay.
So-
Yep, I wish mine would. Okay, next slide, please. Okay, so a little bit about green laser pointer technology. Primarily, it's interesting. I'm going to use a red laser to illuminate. It's interesting because it turns out to be quite difficult to produce green light by a solid-state laser. They haven't found a crystal yet that I'm aware of that naturally, when stimulated, will produce green light in that particular wavelength. Red's no problem. It's relatively easy to do. A lot of the other colors are not that terribly difficult to do. But to produce green light, what they have to do is they have to actually produce light that's initially in the, let me see, that's up in the, somebody help me there, 808?
Yeah, that's in the deep red.
Yeah, deep red. Okay, they take the light out of that initial pump diode, and they run it through a focusing lens and put it through a crystal which converts the wavelength. And you'll notice here they've helped me out with this because I haven't memorized all this. I don't need to know this stuff off by heart. But it starts at 808 nanometer, And this crystal will convert it to two different wavelengths. One of the wavelengths is 1064 and the other is 532 nanometers. So you get this mixed as a result of what's going on, as I understand it, is the atoms within the crystal are excited to a higher energy level by the incoming beam. And when they release that energy again, they release it through two different molecular or atomic transitions that have characteristic wavelengths of 1064 and 532 nanometer. So what you get out of this thing is IR, if I remember correctly, and green light. Okay, 532 is green. Okay, and then what they do, they collimate it a bit and they put an IR filter on the end, or they're supposed to put an IR filter on the end of it, which cuts out the 1064, which is not very good. Thank you, Chris. And what you get is a green beam out the other end of this thing. Notice what I said about they're supposed to, okay? Where do these things come from? China. What do we know about Chinese quality control? Okay. There have been quite a few observations of some of these things coming out with filters that do not do a good job of removing. There have been instances I read about online where they were finding lasers that were rated at 5 milliwatt in the visible band and were putting out 20 milliwatt of IR out of these things. This stuff's dangerous. Next, please. Okay, what is it? Just recapping this, IR can be very damaging to your vision and it's invisible. You can't see it. So the danger of some of these high-powered lasers that you see people fooling around with is not that you'll inadvertently get a little flash with a bright green light. You're getting a flash with potentially a much brighter infrared light that can do real damage to your eyes. Right? So first of all, be very careful where you point these high-powered lasers. If you inadvertently flash somebody in the eyes with them, you may be doing even more than you think you are. Next, please. Okay, so hazards of them. As far as aviation goes, primarily the concern is that air crews who are trying to land or trying to navigate may suffer from glare problems, flash blindness, after images. Now, the Transport Canada would like to tell us in the astronomy community that pilots could suffer permanent vision damage from this. Okay, I did quite a search of the literature, and as far as I can find, there was one instance in the UK of someone who actually suffered retinal burns from a high-powered, they didn't say what wattage, but they listed it as a high-powered green laser. He did it because he bought it, received it in the mail, and immediately decided to stare at the beam to see what the effect would be. And not only did he do it once, he did it in both eyes. and there was an accompanying photograph, I can't remember what they call the internal picture of the retina of his eye, and you could actually see the burn spots on both of his retinas.
Is there a subset of the Darwin Awards for that?
I would think, you know, like you gotta scratch your head and go, what were you thinking? But anyway, it is possible for them to do harm, but I also did a search of the literature, not that Transport Canada gives astronomers, who they would like to frighten off of them, but that they give to air crews to assure them that it's going to be okay. And what they say in that literature is that the probability or the likelihood of actual long-term vision degradation from being flashed in the cockpit is vanishingly small. It's unlikely. However, you know, there's concern over these other issues that have to do with difficulty visualizing what you're doing when you're operating an aircraft. Okay, so it's dangerous, but don't let somebody tell you that, oh my God, the pilot in the airplane is going to be blind. Temporarily maybe, but not in the long term. Okay, there are actually some examples in the literature where they have also done permanent damage to sensors. I ran across an article in particular that a Canon 5D Mark III which is a very, very nice camera that we commonly use, was permanently damaged. The sensor was damaged by being illuminated by a green laser pointer. So it can happen, and it's a real phenomenon. Okay, next please. So hazards to aircraft. Transport Canada image, this is the kind of stuff they're putting out. Yes, in the worst case, and we do want to avoid this sort of thing. We don't want to have any incidents. We don't want to be regulated any more than we are. After all, they're a very useful tool to us, and it just doesn't make sense. You know, like, what's the point? Next, please. Okay, so to address the question about distances, I was talking about extinction. They do decrease, obviously, in intensity the farther away you get. However, of course, this is not a case of light dissipating in all directions. You know, decreases as a square of the distance. This is a collimated beam. It's not quite the same deal. This is being circulated in the U.S. I have no reason to doubt what they're saying. They basically, as you can kind of see here, flash blindness hazards are down in the sub 1,000 foot, maybe 500 foot range. Eye hazard, they say, from laser to about 52 feet out. So don't stare directly into the beam, I guess is the story there. Glare and disruption hazard. About 260 to 1,200 foot out. And you can see these are simulations, but they give you an idea of how much glare they're going to see. Distraction hazards out 1,200 to 11,700. So distraction hazard, basically, ooh, what was that? And they fly into something. Well, okay. So it is considered hazardous, and then they say no distraction beyond about 11,700. So this is in the literature in the U.S. I think this is the kind of thinking that's going around within the aviation community as far as what are safe distances here. Let me see, 11,700. So that's what, about 4 miles out, something like that. Yeah. Something along that line. Next, please, Chris. Okay, so regulations that we're facing here, like we're already pretty heavily regulated. There's a lot of Canadian law or Canadian acts that directly affect or are seen to, have effect with respect to controlling green laser pointers. So just to list a few of them, there's a bit more than this, but I didn't want to exhaust you with all of it. I'm going to gloss over this fairly quick, but just give you a taste of what they say, and I'll leave it up to you to go look up the stuff if you want to read the legalese and get more out of it. I glossed them over for you. So Canadian Aeronautics Act basically is what Transport Canada uses to regulate how flying happens in Canada. I'm sure some of our members who are pilots are familiar with that. More recently, as of about 2011, the Canadian Consumer Product Safety Act is being brought to play against higher powered lasers. Sub to that, and an enabler for it, is the Radiation Emitting Devices Act, and as well as that, for acts like flashing people who are playing games and that sort of thing. It's the popular opinion of law enforcement that falls under various sections of the criminal code. So, for example, assault. If you're flashing somebody in the eyes with a laser, generally it's considered these days to be a form of assault, and whether you do harm or not, they'll decide which section to go after you with. Mischief is a nice catch-all, and if you're flashing traffic on the highway and you bring about an accident, for example, you're likely to get tagged with mischief, either causing bodily harm or whatever. There's various flavors of that. And as well as that, there's a couple of different flavors of criminal negligence. So, for example, the person who hands a high-powered laser to a 6-year-old who proceeds to blind his brother with it would be guilty of criminal negligence, causing bodily harm. Right, so there's a bunch of different stuff that applies depending on what it is exactly that is being complained about. Next, please. Okay, Canadian Aeronautics Act, I'm not going to make you read all this. just point out the green parts. Okay, you're not supposed to do anything that interferes with the performance of the duties of any aircrew member, okay, and blinding them falls under that. Lessening the ability of any crew member to perform that duty, or interfering with any person who's following the instructions of a crew member, right? So basically, that pretty much covers off if you mess with people flying an aircraft, that's what they're going to be after you for. And, I see Chris has highlighted, everybody dwells on the maximum you can be charged with, but basically there's penalties for it, and that's about it. We haven't had a lot of prosecutions so far in Canada, but there have been a couple. There's been a lot in the U.S. There's people serving multi-year sentences in the U.S. right now for various incidents involving laser pointers. Next, please. Okay, Radiation Emitting Devices Act. So I bring this up first because it's an enabler for what's happening under the Product Safety Act, which we'll look at in a moment here. What is it? Blah, 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 blah. Okay, you're not allowed to sell, lease, or import into Canada a radiation-emitting device if the device, and we'll go down to here, creates a risk to any person, okay, of genetic or personal injury, impairment of health, or death from radiation by reason of the fact that it is, and subsection 3, here's where they get you on high-powered lasers, emits radiation that is not necessary in order for it to accomplish its claimed purpose. And you can clearly see that if somebody can go out and use a 5 milliwatt class 3A and achieve what they're trying to achieve, it's pretty hard to excuse going out with a 500 milliwatt and trying to say, oh, I need it for pointing at stars. Right? It's a little difficult. So there have been a number of seizures around stuff that's been coming into the country. People have ordered from Hong Kong or whatever, oh, I want this high-powered laser, and if they happen to notice on the labels and they examine it, seizures and destruction on these things. So far, I haven't heard of any penalties, but they're certainly being seized if they get caught. Next, please. Okay, Consumer Product Safety Act. So where does this come in? You're finding now that your local vendors, your local astronomy shops are not going to have high-powered lasers anymore. As of 2011, there was an interpretation done at Health Canada that basically clarified that Class 3B lasers are deemed to fall under the previous one we were looking at, hazardous radiation emitting devices. They are deemed blanket to be falling under that particular classification in the Radiation Emitting Devices Act, and therefore they become a danger to human health and safety because of, you'll notice the same text as we saw in the previous act, and so they are now conducting visits to astronomy shops, and they're seizing or forcing the re-exportation of devices that are higher powered than are allowed. So Chris was telling me about an experience he had at Starfest earlier this year, where one of the major vendors that had been carrying high-powered laser pointers was no longer carrying them, and the story was that they'd had a visit from Health Canada, and they had been very pointedly reminded that these things are unlawful to sell. Okay, so what does that mean to you and me who happen to have one of these that we got before that interpretation came along? As of this point, if you do something bad with it or you're seen to be irresponsible with it, they can be seized by a peace officer, and they'll probably be directed towards Health Canada and they'll be destroyed. Okay, you'll lose them. However, if you're responsible about the use of them, there is no regulation right now that says that you can't continue to own them. Okay, you have them, you're grandfathered, so to speak. Don't tell them you think you're grandfathered, but basically it's like you haven't committed an offense because you got it before it was an offense to transfer one, but don't get rid of it. You can't give it to somebody else. You can't loan it to somebody else. You cannot transfer it to another person, because then you'll be contravening the Radiation Emitting Devices Act, and you can get tagged there, okay? So
And
if
I can just kick in, what really annoyed this vendor at Starfest, for those of you who know Starfest, you could walk across the field to the swap table and buy brand new 80 milliwatts from individual vendors, unregulated.
Yeah, you bet, because they're small time, they're importing them personally, they're getting in under the radar, and then they're selling them, and of course, now that the shops can't have them anymore, that makes them even more dear, the prices get inflated, and all this goes on until Health Canada becomes aware that this is going on at Starfest and at other events, and we start getting the Gestapo visiting our events, right, because okay, so I need not carry on, but you get the idea. Next, please. Okay, so RASC are very concerned about this because they're potentially going to regulate a very useful tool out of existence. We don't want that to happen. They're very useful to us. Okay, so the position of the RASC, as you know, I've pared it down. Theirs was very flowery and quite sizable, but I just went through and pulled out the salient points, I think. First of all, they say GLPs have established legitimate applications in astronomy. They really are used for legitimate reasons. Secondly, the RASC has developed a voluntary policy rather than being regulated. They've said we've adopted a policy that we developed ourselves that we think is adequate for that. So lay off and leave us alone. That's the idea. And the third is RASC encourages members to follow its GLP policy. Okay, so it's kind of one of those, what you do in the privacy of your own observatory is, RASC suggests that you follow its policy, but there's no way they can force you to do it. That's the truth. It's a question of being responsible with these things. And ultimately, it's the individual who's going to get tagged in a case like that, where you're off by yourself and you illuminate an aircraft. They're going to come get you. They're not going to come get the center. Next, please. Okay, so their policy, so that was their position. Their policy is avoid shining them in the direction of people, vehicles, aircraft, or wildlife, okay? So they're for pointing at stars. Don't point at, things that are alive, basically. Number two, avoid using it near an airport or an airport runway approach. And it's suggested that a 10-kilometer safe distance is appropriate, okay? Number three, use the minimum power you need to do the job. And, as I say, in my opinion, at least 5 milliwatt is plenty. Next. Be aware that distraction and distress can be experienced by anyone, okay, even if the level's well below what's going to cause them actual harm. There have been a number of cases where people have become very distressed because they thought they were being illuminated by a sniper. Okay, there are laser gun sites out there, and some people who aren't familiar with it and they get illuminated by a laser, that's the first thing that comes to mind. It's that movie TV effect, right? Okay, and next, and use good sense in storing them because, it's like any other dangerous device, and I don't need to reel off what those kind of things might be, but children get their hands on them, they're very exciting, they're very interesting, and next thing you know, we have accidents happening or we have them doing things that they shouldn't be. Okay, next. Okay, so just drawing out the 10-kilometer circle. So first of all, I should say we need to distinguish between you as individuals going out and practicing astronomy and using your green lasers to advantage, like I described for myself, and events that are actual RASC formal events, okay? As an organization, if we organize an event, the RASC, that's the RASC, and it's inappropriate for us at one of those events to act in a way that contradicts what our stated policy is, okay? So, message in there is when you're attending an RASC organized event, like an RASC Star Party, you should be acting in compliance with the RASC policy, okay? So here we go, 10-kilometer radius circle around the 4 airports in the area, okay? Carp Airport down there, Ottawa Airport, Rockcliffe Airport, Gatineau Airport. Issue that came to my attention, and I guess what motivated doing the talk tonight, that's where the Diefenbunker is. That's where the star parties have been happening. You'll notice that it's way too close to the airport, for us to be using green laser pointers there. So I'd like to ask at least that people, when they're attending star parties at places within these circles, please be conscious if you're at an RASC event that it's the RASC you're representing. It's not you as an individual, and we don't want to be seen as contradicting our own stated policy. Otherwise, we're likely to have the Gestapo coming and regulating for us, right? What you do at your own events, that's fine, but at the RASC events, let's try and cut that down.
Does
Okay.
the policy mention anything about active airports?
Active
Whether the
airports?
airport's active or not?
No, there's no such, what is it, specification?
Because CARP is usually not active at night, so,
Mhm.
I mean, I was just wondering if the policy took that into account. or not.
The CARP is open at night.
Hold on.
It is open, there are flights come and go through there.
Yeah, but it's not like busy.
Well, basically what it comes down to,
I mean, I've flown
What-
into it at night, right? And
Yeah.
it is open at night, but it's not like it's constantly having aircraft come in.
yeah, I understand, but Transport Canada doesn't place the decision of when an airport is in operation and when it is not in the hands of other people, right? The regulation simply says it's either open or it's not. So as far as Transport Canada is concerned, you know, that is an active airport all the time. But we're not talking about Transport Canada policy, we're talking about RASC policy. An RASC policy is that you don't use them within 10 kilometers. Now, there's no specification in there of active, inactive, or anything else. I'm sure you could make a case for an abandoned airport. Like, I don't think you would get much of a pushback if you said, I'm out at Nirvana, and RASC policy says I can't use a laser pointer there because it's an airstrip. Yeah, but nobody's flown in and out of there in years. It's not an active airstrip at all. But no, CARP is considered to be, you never know when a plane is going to come and go.
So we just won't use them there anymore at the CARP Star Party.
Well, I think that's the idea. You know, I don't want to finger point or anything. I think it's primarily that, you know, the members should probably understand that there's a difference between what you do when you're by yourself.
Right.
Yeah, you're going to make your decisions versus what you do when you're there as an RASC Star Party and you're a representative of the group. And I think I've stretched this out way longer than I should have. Are there any other pressing questions, or?
Do laser rangefinders, what effect do they have?
Well, laser rangefinders typically are not green, and the issue is, no, they're usually red.
Red, that's what I'm saying.
Yeah, red's not an issue, right? It's green laser pointers in particular because of the human eye's sensitivity to that wavelength of light. So it's specifically green laser pointers that are the issue. Yep.
So according to that map, Peters Point would be okay.
Yes.
Yes, just fine. Yeah, anywhere outside of there.
Our next speaker from Elmer is fine.
Yes. Okay.
I'd like you to move the circle just a millimeter, then I'll be fine at home.
Yeah, fair enough. Well, what you do on your own time is your own business, Chris. Right? Yeah, we're only talking about RASC events. Yes?
So what about the Cumberland Museum, or the Cumberland Star Buddies? Are they?
Cumberland looks to be just outside. It looks to be far enough from Gatineau Airport. I tried to get these circles quite accurately, you know, to reflect 10 kilometers, and I tried to locate them as accurately as I could, centered over the airport. So this should be a reasonably good representation of where the policy boundary is. But understand as well, you know, nobody's going to run out there with a tape measure and go, oh, you're 3 meters inside, right? It's not going to work that way. I think basically if you can say, we're in Cumberland, we're 10 plus kilometers away, then that's the end of the question. You know, even if you were, you know, I'm right on 10, maybe I'm 9 3/4, whatever, probably nobody's going to make a big fuss over
Take a note
this,
on this
right?
slide where we are right now, where we hold star parties at the museum. We're well inside the circle.
Yep.
Actually, I think I'm gonna have to hold the questions on that.
Yeah, you bet. We're
pretty packed tonight. I'm sure
You
Bill
bet.
would volunteer to stick around and answer?
Yeah, sure,
questions
I'd be
at the
happy
break
to.
afterwards?
I'm not a legal authority on this by any means. I've done a lot of reading on it over the last week or two, I guess.
Thank you.
So, you know, I'll answer what questions I can. Anyway, one last slide, and clear skies. Thank you.
All right. So up next, we're going to have an update on the Pontiac Quebec Observatory Initiative.
I've got a problem.
You've got a problem?
I've got a
Oh,
problem.
problem? Okay. And there's the laser if you need it.
I'd like to introduce you all to Starshine. This is the latest addition to our family. My daughter went to a Build-A-Bear birthday party last week and came home with this, so that tells you how infused the whole culture of astronomy is in our family. So, Starshine. So my name's Stefan Papa, and I'm the president and founder of a very small group that is taken on trying to establish an observatory in the Pontiac region. And this is actually the third time that you have. Do I advance? Okay.
Or I can,
This button?
right button.
Right. Perfect. Thanks.
Center laser.
Okay, thanks. So yes, and so our first presentation to this group was in spring of 2011, and then we had a subsequent update that was around the Pepsi Canada funding contest. And since our first encounter, we have incorporated as a not-for-profit, and we've set up the website astropontiac.ca, which right now is quite bare bones, but it gives us a presence on the web, and as you will see as the presentation unfolds, is going to become much more active. The website was actually started for us by one of our board members and among RASC's newest members, my friend Paul Sadler, who's in the audience tonight. And we've also been working to bring attention and support to the initiative. So we've come up with a concept, the Aylmer Astro Night. And the Aylmer Astro Night is to, for one evening, demonstrate the potential of a multifaceted public astronomy facility in the region. And the goals for the evening are to foster an appreciation for astronomy among the general public, promote awareness and community support for the Pontiac Observatory concept, and to raise funds for a portable digital planetarium that would allow ongoing efforts to build community support and raise funds for the observatory. So the theme is to bring together individuals and groups from throughout the region who are inspired by space to innovate, create, and discover. So just a quick rundown of the main elements of what the evening would be. Our planned date is Tuesday, October 29th. It would be a backup of October 30th if the skies look more promising on October 30th and we had overcast skies on the 29th. There'd be an indoor program featuring static displays and speakers with presentations in French and English from one or two amateur astronomers. Sylvie Letourneau is actually going to be one of our speakers. She's kindly volunteered. I'll be speaking about the astronomy, the observatory initiative, and also we're going to have a feature presentation from Marc Arnaud. And also we'd like to have an outdoor telescope viewing, a star party, based on volunteers bringing telescopes and, from the looks of the circles, your laser pointers if you're so inclined. So partnership has been something that has really been has been something that's really been coming to my mind a lot as I've been going through this, pulling this together. The Ottawa Centre RASC has shown tremendous support in the past, having me speak twice, provide updates. Also, Mike Mogadam and Sylvie Le Tourneau have just been so incredible in putting my issues in front, making sure that I have a place in your discussions when the time comes. And it would be such a thrill if members of the RASC would come out and participate. And this could be coming out as a visitor, providing a display for one of the static displays. If you have something like if you do astrophotography and think it would be interesting to share how you do it with some equipment at a table that people could mill around in and discuss, showing off your viewing equipment. Some of this stuff that amateur astronomers have is almost as spectacular under room lights as it is collecting light out on the observing pitch. If you'd like, bring a telescope and set it out under the stars. And also, if you can't make it, if you can't visit, it would be great if you could spread the word. And I have sent the RASC general mailbox a formal invitation asking people to spread the word, come if you can, and help make this evening a success. The location, when this presentation was put together, I didn't have a location yet. We were working on a couple of suboptimal sites with the city of Gatineau and really had a big fish getting the local high school, middle school, which is a little bit out of the light footprint of Aylmer, to host us. And on Thursday, I spoke with the principal, and it was just amazing because, I'm tentatively saying, well, how much is this going to cost us? But thinking of asking the question, and he tells me, when I tell him what we're hoping to bring and do, he says, so how much is this going to cost us? And so this is one of these things that's really encouraging, that, if we could bring this to an area with a relatively close population, a place that people don't have as much exposure to the star parties, I think that we could really have something that brings attention to our cause, but also brings a lot of new members to the RASC, or at least curious people like myself to come out to star parties and things like that. Also, another thing that might be helpful is if any of you from RASC might have a couple of astrophotographs that you might like to share, that we could maybe sort of put on a 4x6 print off as like a souvenir for some of the people who come out to the event, that would really be a kindness. And in terms of what we would hope to build on off of this, we would maybe look at a crowdfunding initiative through something like Kickstarter or Indiegogo to try and build on some of the momentum that this evening could bring. So just briefly, because I heard the chimes, probably almost break time now, but if anybody has any questions they'd like to ask me here, I'm not sure if the MC feels that there's time for that, but I will be outside during the break to answer any questions as well.
That would be better, actually, if we could hold them, because we are, as you heard, the gong there, and so we're running a little bit behind.
Okay, but thank you very much.
Thank you. You normally hear from me in my official capacity as secretary every November, next month, and you will, in that capacity, dealing with the obligation to and the opportunity to have nominations for every elected position in the centre that will come forward at the annual general meeting in December. But I wanted to come to you first because of three particular needs to put these ideas in your head, because they do take time to fill. As most of you know, our tradition in the club, even though we do elect all our positions annually, we typically actually change people only every second year, president, vice president, and meeting chair, and so on. And we got into a strange situation many years ago where the meeting chair is on the off cycle with all of the other positions. So this is an off year for most positions in elections, but it is the end of already, amazing, 2 years have gone by for Paul, so the end of his term is coming up, and we will be looking for a new meeting chair. What most of you probably don't know is that the tradition in the club that's sort of unspoken is that the current meeting chair typically finds his own successor, even though there's also a nomination process through Al Scott, who probably should be here, but we didn't know if he'd be here today. But Paul has undertaken the task of finding the new meeting chair. He's already involved in doing that and is looking out for people. But it's not an easy position to fill, and I'm sure there are people here that Paul may, and myself and Al may not be aware of. So it's really a very open call to anyone who has an interest in taking on a meeting chair, taking the meetings in a slightly different direction, or maybe it's a chance for you to prod the person sitting beside you, or go behind their back to Paul and say, why don't you try prodding this person? But we're open to suggestions. The general, there's no rule about this, but the guideline that we've used is that a meeting chair is someone who's been up at the podium before, has talked once or twice, given some observations, so we have some idea what we're getting into, and not a total stranger or risk to the club. But we're wide open to suggestions. So if you have thoughts for yourself, for someone else, see Paul or myself or Al. Secondly, unfortunately, we are losing our treasurer. Hans Brouwer has been in the role now for many years, done an admirable job, but like so many of us, he's got competing interests at work, at home, and he thinks his time has come up that he can't put more time into it. It's a less glamorous role than meeting chair and president, less visible, but equally critical to the functioning of the club. And here are requirements for a treasurer do not mean that you have to be a chartered accountant or have formal training in accounting, but you certainly always need a comfort level in running basic accounting programs and having assistance from others. So Hans is very much looking for help in finding his successor so that he can get back to his other duties. And for the third position, I'm going to turn it over to a much more qualified person to talk about the outreach coordinator. Sylvie?
Good evening, everyone. I'm only qualified to talk about it. So, we received this message from the rebellion last month where we desperately need an outreach coordinator, and we are basically looking for the next Obi-Wan Kenobi. That's the message from Princess Leia, not me. And we do provide the lightsaber, and it's just so funny because I wrote that before I saw Bill's presentation, and I was gonna say that the lightsaber was actually a green laser pointer, so it will be around 5 milliwatts, no more. So the next person that could be the outreach coordinator would have to be one, able to answer emails, because that's mostly what happens. People go on our website, they see what we do, they're interested to know what else we can do for them, if we can go on site to a telescope for them, etc. So they send us outreach requests, questions about star parties, questions about schedule, questions about tons of things. How do I buy my next telescope? Whatever, that's the main thing. Then you need to be able to, again, turn around and send emails. So far, so good. I'm pretty sure everybody's got an email account in the room. Or maybe not the young little guy was sitting in front of me there, but everybody else.
Are you kidding?
You have an email account? Oh, he has an email account. I'm in trouble. Okay, so if you're able to send an email, then you can turn around and request volunteers for those events. You can organize those events, whatever that entails. And also, we have a desperate need for somebody that is able to send an email to request outreach material, because that's all it takes, but you need to have the time to send that email. Now, I'm allergic to emails, so I cannot have this job. That's why I'm out here to tell you. But I love talking to people, and that's the third thing. You need to be able to talk to your volunteers. You need to be able to go get them individually sometimes. To organize events, you need to talk to everybody. You need to promote the events out here at this podium. If that's a problem, I have no problem coming on the podium and talking about events. But today, the event we had was for Stefan, and Stefan came up here and talked about it himself. That's great. And then ultimately, the person can attend the event. It doesn't have to be. If you have another person you trust and that is willing to go, you don't have to attend the event. But the interesting thing is most of the events don't happen because we have a hard time coordinating to get volunteers for them, not because that there's no request, is that we don't have enough people. So just like the event for Stefan, we need people to volunteer. If we don't have any volunteer, we don't have any outreach. That's as simple as that. Any questions? Or do we all go for a break?
Not quite.
Oh, watch it. So, no questions? Oh, good. I'm going home. No. See you at Kelsey's.
Thank you.
So nice that you could join us, Sylvie. And the rest of you, do not fail us.
All right. On that note, now up next, the one and only Chuck O'Dale with a trivia question for you.
Something to think about on the break. Wow, look at all the craters. I wonder.
There are holes in the ground.
The holes in the ground, yes. Okay, craters. I pushed the wrong button. Did I?
Yes.
Right button?
You're either right.
There we go. Yeah, I'm ex-military. I still haven't got it right. Okay, Tycho, 86.21 kilometers. On Mercury, similar size. But geology, Mercury and the Moon are a little bit different size. Therefore, the craters have a little bit different characteristics. And most of the characteristics are very connected to the size of the two bodies. But there is a conundrum. What is it? Now, whoever gets the best answer wins a shatter cone. Something to think about on the break. Have a good break.
All right. Mr. O'Dale, are you going to come and give us the answer that we're all waiting for?
Well, I tried to make it Google-proof, and I think I did. Nobody got the answer.
Can we guess?
You can guess.
Does it have to do with the lower gravity on the moon? That the craters are the same diameter, but the one on the moon will be deeper. If you're standing on the one on the moon, you're not going to see, because of the curvature of the moon, you're not going to even going to see the far wall.
Kinda.
No shatter cones.
No shatter cone.
I laughed enough, I thought, you know.
Yeah, no, that's basically I mentioned that the different gravities on the two planets, or the Moon and Mercury, do different characteristics of craters, but I'll explain them here. We have two craters, the Moon and Mercury. Basically, Mercury's a factor of 2 of everything greater than the Moon. Escape velocity, diameter, and gravity, and so on. So the characteristics of the crater, because of this differential in gravity, you have the depth is less on Mercury because the crater walls are smaller because of the increased gravity. The crater floors are flatter. The ejecta blanket, the ejecta goes out further on the Moon than it does on Mercury. So everything sort of is copacetic with increased gravity on Mercury. Therefore, this kind of characteristic on the crater is intuitive. But there's something that is not intuitive. And I mention this because it could be, I just mentioned here, basically the Moon is half of Mercury, or Mercury's twice of the Moon. And the debris goes further on the Moon, almost a factor of 2. So, what is the conundrum then? Well, this could be a PhD thesis. The rays, we've all seen Tycho on the Moon, and I forget the name of the one on Mercury here, but they're exactly the same size. But for some reason, the rays on Mercury go almost a factor of 2 further than the rays on the Moon. So, PhD thesis, it should be the other way around.
Okay.
But basically, Mercury has twice the gravity, but the rays go twice as far.
Higher impact velocity?
It's an awful lot closer to the sun, so an impact velocity is going to be a lot higher.
Give them the shadow cone.
Well, let's go back. Escape velocity. Escape velocity was a factor of 2.
No, but I'm talking, this is orbital speed around the sun.
Closer in?
You're an awful lot closer, so your speed is going to be higher and the impact.
Write your thesis, Nobel Prize. It could be. I got this data from Ronald Greeley's new book called Planetary Geomorphology. It's basically Interplanetary Geology 201. It's pretty good. And that's where I got the info from. So, PhD thesis coming up. Thanks very much. No winner. By the way, I just wanted to mention, last month, Tim Cole won the Shatter Cone, but donated it to the prize.
Super. Thanks,
So,
Chuck.
make a good recruit for next year.
Of course, you could always break it and half to Rick and half to, no? All right. Okay, time for our observations. And as I mentioned, we have some really nice stuff this month there. So glad to see people getting out and taking advantage of those skies. Paul Commission, unfortunately, is not able to attend tonight. We do have a couple of slides from him, so Glenn LeDrew is going to address those for him. Glenn?
Yeah, Paul's still recuperating after his little visit in the hospital in the early part of September. This was taken from his observatory with his 14-inch camera, or telescope, the new Universe camera, and it's of course of M13. It's not the best of images because number one, the seeing wasn't so good, and we were also binning 2 by 2 pixels, and it was a fairly bright, moony night, as it were, as well, and the exposures were kept kind of short as a result. And anyway, so you're seeing the size of the cluster. Whoops. Back. The main part of it is relatively small, but on star charts, whenever you see it plotted, you know that on either side of M13, there's one 7th magnitude star, and just out of the lower right corner would be another star that form a fairly equally spaced arrangement. And you'll notice that on star charts, the size of the cluster is plotted as fairly big compared to the space between the stars. Visually, you mostly just see the denser concentration of stars near the middle where the density is high enough, but at least in the image you can see certainly some of the more scattered outliers spread over a good area as well, in spite of the short exposure. This was a different image where I had really kind of zoomed in on just the central part of the cluster itself, just to show some of the difference in the colors of the stars. With a big telescope, you can see the red giants, especially if you have a telescope, say about maybe 12 inches or thereabouts, 10 to 12 inches or bigger. The red giant stars show up as a nice kind of a yellowy orange color superimposed against the kind of colorless glow. But also in the cluster, there's a number of what are called blue stragglers, and you can see some of the little kind of bluish cyan-colored little stars of intermediate brightness scattered about the field. But there's one particularly bright one here that shows up in many images I've examined, and it's included sometimes in the plot of the HR, or color magnitude diagram, of the cluster as well. And I'm wondering if this could be an almost a different kind of blue straggler that's extra bright, perhaps because of two somewhat more or even more than 2 stars perhaps that have coalesced to form effectively a brighter, hotter star. It's something I'd like to find out more about, and it's perhaps something that anyone interested in could look up themselves to see if there's anything in the literature about that particular extra bright star, to see if it's a blue straggler or not. On the same night, we were trying to get a picture of that nova in Delphinus. First of all, while we're in the area, it's only about 3/4 of a degree south, is the blue flash planetary nebula, NGC 6905. And in the full frame of the camera, being only about the size of Jupiter, it's not very large looking at prime focus, so I just did a zoomed in crop, just so that people, especially near the back, can get an idea of some of the interesting little structures, as well as the fairly bright central star on that planetary nebula as well. And I do believe that's it. Yes.
All right.
Thanks.
Thanks, Glenn. And thanks to Paul. John, come and show us what you got. You got some really nice stuff here this month.
Thank you, Paul.
You're welcome.
So last meeting, the theme was kind of like challenge to just take some photos of Moon and Venus when they're out together. And so like you've all experienced the moon when it's close down to the horizon. It's kind of like when you see it, it's like, wow, look at the size of that moon, right? But then, as you can see, like after you take the photo, it's like, what happened to the moon? Did it shrink or what? Right? So I was thinking about, well, how do you bring that same kind of effect, to the photo that when you see it live? And like we all know, it's kind of like an optical illusion, but it would be still nice if you could kind of capture that illusion as well. So next one, please. So this is the same moon, and I didn't Photoshop it. So what's going on here is that I used a telephoto lens, and those trees are actually like half a kilometer away. But because of the, well, it's a combination of the telephoto lens, because I used a 400 millimeter lens, and I have a full frame sensor camera, so you get the wide view. And those two combined, and the fact that trees looks like they're in front of you, makes it look like the moon is huge, but it's still the same size moon. Next.
You got one more.
Yes, this one, I took this one in June of this year, and I was just, well, we had our swap meet here at RASC maybe a month before that, and I picked up an old telescope from a member here who didn't need it anymore, and it's like a 500 millimeter focal length and a f4.5. So I just put my camera on it and kind of angled it against the roof of my van, and I took the photo. So that's it.
Excellent. Good work, John.
Thank you.
Nice detail on that, John. Excellent. All right, Francois. There you are. Maybe there somewhere.
How do you use the pointer?
Laser in the middle.
No. Okay.
Yep.
Okay, so I just want to show you this photo I took of the crater Shikard. This was on a 12-day-old moon, so 2 days before full. Shikard's a really interesting crater, I find, because it has a very disrupted history. For example, there's a lot of modeling that goes on inside this crater. Like you can see, there are different shades in here. And a lot of the reason you get these different shades is because you have a lot of lava flows that have occurred over time. Another interesting thing is that there's lots going on. Like you can see a few, I think these are craters, like you can see a few spots in here. And these spots are a result of the fact that you have a lot of impact debris coming from partly the crater formation itself, but also from the formation of Mare Orientale, which has led to this crater having a bunch of crater chains, for example. So this has been much affected by other craters around it. Now, an interesting thing to note is to compare this to, say, Tycho right here, which is that Tycho is 85 kilometers across, like Chuck said. In the meantime, this has a depth of 5 kilometers. Now, comparing it to here, we're viewing it at an oblique angle. This, remember, is a 12-day-old moon, so this is the terminator, and we're seeing a bunch of oblique images here. So if we were to see this head-on, this would be 3 times the diameter of Tycho, and yet the base is actually only half as much as Tycho, almost exactly half. So this is a very flat object. And it's an interesting comparison to see this monstrosity compared to Tycho, where the depth far exceeds its width. So a nice comparison, I thought, and it was nice to see this crater at an oblique angle because you can see the rim here in a bit of detail, considering that it's only half of this one. Thanks.
Thank you.
Mr. Webster, where are you? I know you're here somewhere. There you go.
Well, like Paul, I was looking at the NOVA and spotted 6905. This was back in September 5th, using my 12-inch Dob. And that's I have the specs here somewhere. It's a 12th magnitude planetary nebula. And I was really struck by his photograph and the comparison to the sketch. Is that easy to flip back and forth? Paul's nebula?
Way back.
There. And then back to mine.
Don't linger on Paul's.
No, so you can see, I mean, on the photograph, the dark lane area that I have isn't I'm not seeing as much detail as the photograph did, but I am getting this stuff in here. My brain's not working tonight. The dark, or the brighter areas, I guess, is what I'm getting. I didn't see any blue though, so no blue flash. Next one, please. Okay, so this is NGC 7027 in Cygnus. And does the nebulosity show up around that? Yeah? Okay, good. Hi. So that's the same night, a fabulous night. If you don't remember, it was the night before last month's meeting. It was spectacular. These were done in my backyard in Orleans, opposite Place d'Orleans Shopping Center. So lots of light pollution, but I was still picking this stuff up. These are both done at 375 times magnification. And this is a 9.6. And it was really interesting because you could quite clearly see the two separate bright areas with the dark lane between them and then the irregular nebulosity around it. Next, please. And then from August 17th, a lunar sketch. I like to do my sketching directly in my logbook, and so I tend to work with with pencil on white paper. But a technique that I really like is using white pastel on black paper, but I hate doing it at the eyepiece. So I tend to do reference stuff and maybe the odd photo, and then go do the sketch later. I just find it too hard to work in the dark with that combination. But what caught my eye is crater Liebig and Mersenius. And what really caught my eye that night was this really long peak in here, and then the other one in here. So I think that's off of Liebig B, I think. Do you know, Brian? No? Anyway, that's that one. And then I have one last thing for you. It's this. Does anyone know what that is? Close. It's hollow. That's a 2-inch pipe connector, PVC pipe connector. Inside, there are 3 little felt pads. Total cost is under $2. And it makes a great dew hood for a 50 mil finder scope. So, okay, thanks.
Thanks, Gordon. Rick Wagner, you got some awesome stuff for us this month.
And the right button. Okay, so it was a good month. We had a lot of clear skies, actually. I think I started this set of images on probably on September 5th. So this is a 90 millimeter refractor, an SBIG ST2000 monochrome camera. All H alpha shots, because most of them were taken through the full moon period. Whole collection of emission nebulae. So these are clouds of hydrogen that are normally present around forming stars. And so you can see how it kind of forms a cup. And so what we've got is some bright stars in the center that are actually, the illumination is pushing the cloud away and illuminating the inside of it and causing it to fluoresce in hydrogen alpha light. And so the filter just picks out just that particular color of light and allows me to image when it's moon or indeed even in light polluted skies. So this is what I do is I take a whole series of 10 exposures, each 1,000 seconds long, and then stack them all. So this is a 10,000 second exposure, essentially. It's just under 3 hours. And this is Nebula 7380 up in Cepheus, southeast Cepheus. And the Pac-Man Nebula, NGC 281, is in Cassiopeia. And it's actually quite a bright one, quite easy to see in a telescope. Even a fairly small telescope will show that. Another H2 region. Also 10,000 second exposure. I actually managed over the past about 15 days to do 9 all-night observing sessions. You can tell I'm retired. This is
Another one.
yeah. This is Sharpless 2-132. Stuart Sharpless, back in the 50s, actually went over the Palomar Sky Survey plates looking for H2 emission regions, and created what he considered to be a complete catalog of all the H2 regions visible in the sky, about 315 or 320 objects. He's actually got some galaxies and planetary nebulae in there as well. And of course, most of his catalog, or at least a lot of his catalog, is also duplicated as NGC objects and Messier objects. But this one I noticed in, if you have Starry Night or the old Desktop Universe, Glenn LeDroux, I think, actually did the outlining of all the nebulae. And I just thought it was really cool that this shows such a nice little puppy dog. You can see its head up here and its legs down here and a nice little pert tail sticking up. My only confusion is why he has this odd Dolly-esque mustache. But
Birth deformity.
yeah. This is also a 10,000 second exposure.
Please don't tell me I've watched that.
This is the Heart Nebula. There's actually another one down beside it, which they call the Soul, so it's the Heart and Soul. Another Sharpless object. It's up just off the southeast end of Cassiopeia. This one is actually a fairly large object. It's very dim. Even with a filter and a fairly good sized telescope, it can be quite difficult to pick out. The brightest area is up here, is not too hard to find, but these parts down here are more difficult. And this is actually a large enough object that it's actually, I've done it as 4 separate panes, each of them 10,000 second exposure. So this is a total of 40,000 seconds, which is getting long. And this is the North American Nebula. You can see the obvious shape here. This one's called the Pelican. You can see his beak, the eye, the remains of the head. I was quite amazed. I was out sometimes while I'm imaging like this, if it's a clear night and good conditions, I will also have my 12.5-inch scope out. And going through this area with the 12.5 and a UHC filter, you can actually see an awful lot of this nebulosity, these areas down here. And of course, this is probably the brightest and highest contrast areas around the Gulf of Mexico, and it's quite obvious if you're in tall, dark skies. This one is actually quite a large image. I started off with just sort of 2 or 3 or 4 frames covering in the middle, and kept thinking, well, I've kind of cut this bit off, so I'll add another string across here. Well, I'd like to get those. And then there's these dark nebulae up here. Barnard did a catalog of all the dark nebulae. And so by gradually expanding out in all directions, this is actually 22 separate frames now for a total exposure of 110,000 seconds, which is about 30 hours. But on the other hand, it is a 25 megapixel image, so I'm going to try and get it printed up as a 30 by 40 inch poster. We'll see how it turns out.
So your resolution is so good. Are you sure you didn't take this from the Hubble Space Telescope?
Yeah, well, it's by taking lots of pictures and then squeezing them together, the resolution appears to get to very good. So. Thank you.
Awesome. Thanks, Rick. That's beautiful work. Yeah, 40,000 seconds. Yeah, retired already. Yeah. Don't you love that? All right. What do we got here? Oh, Milky Way Rising, Rick. Milky Way Rising. It's not yours? Well, that's mine then. That's one I took. That's, Rick claims that that is not his work, so we're not sure. Does anybody recognize that work? Did we botch it? No? You sure it's not yours, Rick? Okay. Okay.
How about that?
How about that?
With it?
It looks like a beer can shot, huh? That's got to be one of your beer can shots. You use the camera that you just emptied.
These would have been submitted last month.
I sure think they came from you.
Yeah, well, I recognize this one. I don't recognize the
The
Milky
previous
Way.
is the same
They're
image.
advertising images from our sponsor.
The previous image is the same image without.
Oh, okay. All right, all right. These were actually done,
These retired people who drink beer all the time.
yeah.
Beer can.
Well, I can't imagine when I would have submitted these. It must have been like 6 weeks ago or something.
Same email.
Well, we've seen
No.
this presentation before because we've seen the animation showing stuff moving across the sky.
Yeah, I think this is a repeat.
Could be.
Okay.
I think it's a repeat
But it's good work.
from August.
Still good
We're
work.
gonna run through them anyway.
I think it's just the two anyway.
Yeah,
right?
that's
Yeah, okay. Okay. And, yeah, that's me. I've got a couple for you this month. This one I thought I'd throw in. This is something I shot near my place. I have a thing for dawn light. It's one of my favorite times of the day. And I figured with the clouds and the storms we have rolling through, a little sunshine is always a good thing to have, right? So, yeah, just thought I'd throw that one in for you. And when we do get the clear nights, I did that one as well. That's the Helix Nebula in Aquarius. It's a large planetary nebula. In fact, it's one of the, I believe it's the closest one to us. It's only about 700 light years from here. And the progenitor is that little guy there, big guy there. And essentially, this is what's going to happen to our sun in a few billion years downrange when our sun gets old and cranky and sloughs off its outer layers of gas into space, and then later fluoresces them, and causing a similar structure there. So very similar to the Ring Nebula, but again, much closer, only 700 light years from here. And that is a 2-hour and 10-minute exposure on an 11-inch telescope using a Canon 60DA. So nothing too fancy there, but I was pleased with the result there. And you can see this one of the interesting things with the Helix is these knots that you see here. There's a few of the larger ones that show here, but these were discovered. As I say, this is the first planetary nebula where these were discovered, and there's I think they've identified over 10,000 of these knots. They're not quite sure what the origins of these things are there, but they're radially outwards from the center, and the knots themselves at the end of the tails are about the size of the solar system. So they are a big structure, and we're not quite sure of the mechanism yet. But anyway, interesting object to have a look at. It's fairly dim. It's very, very big as well. And it's a bit of a tricky thing to capture because in our part of the world, it only ever rises about 24 degrees or so above the horizon at its best. So that was it for me. We've had some good weather.
So Chris Tarrant notified me that when he was going across the bridge between Canada and Stittsville, there's a new bridge over the Carp River. It's barely a river anymore, but anyway, there's a bridge nonetheless. Very nice looking bridge. And he noticed that there was some constellation cutouts on the along the bridge. So if we go to the first slide there, so this is a bridge looking back toward Terry Fox Drive. This is looking from the Stittsville end right toward Terry Fox Drive, just down the end, and the support structures on the for the bridge have these cutout sculptures. If we go to the next one there, please. All right, and it talks about how the city, when they were building this new bridge, they got these different artists to do different types of artwork to beautify the whole new section of Stittsville. So over on the right, it talks about the artists Alistair McRae and Nagar Saifaliali were doing constellations of the sky. They wanted to get some sky images in there. So we'll go to the next one. Okay, Chris, sorry. All right. So on the one side here, it's hard to see on this side. Is it the center for the laser? Yeah.
Middle button.
Okay, yeah, got it here. So here we can see they've got they had a Aquila here, and facing the right way, but they put Ursa Minor facing the wrong way. I was trying to figure out now why would they have done that. On the other side of the bridge support, you see Cepheus and Ursa Minor, but everything's written the right way out. If you go to the next one, we went and found some other ones. So this is a beautiful one. They've actually put some colored beads in here so everything lights up nicely. So you can read the links from one direction and you're reading Ursa Minor when you're coming from the other direction. So if you walk between Canada and Stittsville along that roadway, at some point you're going to see along all the lampposts all these nice sculptures that were done in these sheets of metal. Very, very pretty. All right. And now to the main event. Just like it says here, a dream come true. My daughter Emily is here with her fiance Chad. Emily's a PhD astrophysicist at Western University in London, and she's got this cool pal named Anne-Marie Pickersgill. And Anne-Marie is working with the thin slices of the Apollo lunar samples. So she very kindly came in. She wasn't feeling so hot that day, and she very kindly came in and hauled out the samples so that we could have a look. And so we'll go to the next one, please. So there's good old Anne-Marie, looking all perky, even though she wasn't feeling so perky, but her enthusiasm, boy, it's something else, something else. So the setup there, she's got her microscope. We're putting these, they're basically, you'll see one in a second, is a thin slide, a round slide that has a very thin shaving of slices that were of the samples that came back with the Apollo astronauts. And so she's got all the cameras set up through it, so we can see on the screen if she's using different types of polarized light, so you can see different aspects of it. And then she hauls up on her laptop which original sample it actually came from. So if we go to the next one, please, Chris, thank you. So here's her little box of samples, and it was quite an elaborate security procedure that they have. So before the lunar receiving laboratory would send any of this stuff up, there had to be the proper security measures, which is a very good thing because nobody's allowed to own any of these, so these are on loan. If anybody tries to sell an Apollo sample, it's illegal. It's a stolen sample, in other words. So it's a strange numbering system. The first number here, this is actually an Apollo 11 sample, and then this is Apollo 12. It wouldn't be a 10 because Apollo 10, even though they got down to 50,000 feet, they didn't get it down close enough to run a rake across the surface of the moon to scoop anything up. So there's Apollo 11, 12. And there's 15. I thought we had a 14 in there as well somewhere, but maybe not. All right, the 6s, those are Apollo 16s, and some Apollo 17 samples here. And here they all are in their slides. And some of them they're just little round slides, and you pick them up. I didn't realize that there were no covers on the slides. So on most of the slides, it was just, you actually could have put your finger right on the sample. I would never have done that. So she said, oh, actually, we bump against it all the time, but that type of thing. But that stuff happens, but there it is. So if we go to the next one. All right, so here's a nice combination of shots that I think tells a story because, I've got, as many people here do have a very high interest in the moon. But here's Harrison Schmitt, the only scientist ever to go to the moon with the last Apollo lunar landing mission, Apollo 17. Here's Harrison Schmitt when he was at Western University with Emily. And Emily, were you showing them photos of my meteor impact experiment? I think, yeah, okay. And here he is lifting off the moon. And then it got to me that he was there working on the moon, getting filthy, filthy, filthy in the dust, right? He comes back, lifts off with the samples. He's carrying the samples that he's carrying in there. All right, and if we go to the next one, please. And there's a piece of what he was lifting off the moon with, right there. And you look at that under the microscope. I was holding onto it like it was and she said, "Relax, relax, Brian. It's not you're not going to drop it." And very, very interesting to see. You look at the different samples. Simon, I wish you could have been there to see that. Maybe you've seen these already. But you look at the differences between, say, the Apollo 11 samples to the Apollo 17, or I'm sure I saw one from 14, but I know the Apollo 15 samples were much different again. And all has to do with the various elements that are included in the sample. I mean, inclusions in the sample. Is there any more after that? If you want to go and look these things up, I could actually look up the sample that I was looking at. I could see what the parent rock was. So if you go and Google from the Lunar and Planetary Institute, the Lunar Sample Atlas, there it is right there. So the sample number that I was looking at on that one, there's an identifying number on the sample, and I could go and look it up online. It's got an A number, so
an ABC or whatever it was, but you have the main sample, the rock, and it was cut into the thin slices. And what was Anne Marie's line? She said, I just love thin slices. They're awesome. But you can go and look up the parent rock, and then not all the individual thin slices, they're all cataloged elsewhere. And if we go to the next one, all right. So here it is. This is that Apollo 17 sample that I was the one that I was holding up there. This is the parent rock. So you look in the sample catalog, and it shows you a photo of the top, from the bottom, and the side view or whatever it's going to be. So there's a lot of information to be had out there, and I think is that the last. Oh, and here's the whole gang. So here's Emily, here's Chad. They're in the back there. Bridget didn't come down tonight, and there's Anne Marie showing us. This is unbelievable. Just unbelievable. If you ever get an opportunity to do something like that, to get that close to the moon. I have some moon dust that I actually bought from Ron St. Martin here. And what I'm going to do is I'm going to put a little bit in a vial. Because I asked Anne Marie, do you have any moon dust of your own? She goes, well, no. And so I'm going to give her a little sample of that. And speaking of moon things, Francois, where are you? Yeah, I thought that was a really great presentation you made about the comparison on the craters there, and I'm going to set up a little vial of it's going to be a small amount, but I'm going to give you a little bit of moon dust yourself. All right? All right, and just close up photos. You can go and look at these online as well. So just to see what how the inclusions work and crystalline structures and everything else. And I had to somebody asked me, did you do an IP shot? Well, I did, but it's not great. Thank you, Anne Marie. And thank you.
All right. Thanks, Brian. Buying moon dust, eh? You buy bridges too? Yeah? No? Okay. Yeah, that's the one. All right. All right. Well, again, thank you to Simon for offering to push his talk into next week. Sometimes Chris and I get seriously over-ambitious with the number of slides we'd like to present in one session there. So it's already 10, and I didn't want Simon to be rushed with his presentation at all. So next month, if that works for you, it certainly works for us. And I apologize for running over.
No problem.
Thank you. So Stell's with us today, and her pick of the month is the Night Sky Observer's Guide, Volume 1, Autumn and Winter, very appropriate. And so if you'd like to talk with Estelle, she'll certainly be available there. Public Star Party, yes, Saturday, October the 5th, not going to happen, right. Rain date, yeah, I don't think it's going to happen, unless it clears up, you never know. The weather's picky this time of year, but failing that, 2 weeks or 3 weeks after that, on Saturday, October the 26th. Again, at the Carp Library, Diefenbunker, and leave your green laser pointers at home, please. Thank you. All right. If you're a first timer and you're not sure where the site is, fairly easy. They're just along the 417 west from Ottawa, and straight up Carp Road. Go through the village of Carp there, and you'll see a sign for the Carp Public Library. That the Carp Road will take you there, and you just deke down this road. There it is there. Yeah. Got a parking lot there, and the library is there, and the Diefenbunker complex is there, and we tend to set up our observing stuff right in the tail end there, and it's a beautiful western vista there. Out, it's sort of on a ridge, and looking out over the west where there's very few and very little in the way of towns and stuff. So it's a nice site and a good time. If you've never been there, certainly something you should check out. Okay, and oh yes, this notice that Melanie posted or just brought to my attention just a little while ago. There's going to be a public astronomy lecture on the Northern Lights, and apparently this is quite a this is going to be quite a good presentation. There's a well-known Norwegian astrophysicist, Paul Brekke, I believe his name is. And he and with a colleague have recently published a book on on the Northern Lights, where they talk about the myths and the modern, right up to the modern science behind them. Also, I believe there'll be, I believe in the book itself, or at the lecture, they'll make available tips on how to effectively capture that. He's done some really, really nice imaging there. And I believe, is that a free lecture? I believe it is, eh?
I don't know.
I'm not sure. That's a good thing. I should have checked on that. I'm not sure if it's a free lecture, but at any rate, it's November the 14th. We'll remind you again next month because that is still about 6 weeks away. But 7 p.m. on that Thursday evening, right here where you're sitting. So if you want to take that in, there's bound to be some pretty nice eye candy there with the aurora shots. All right, and just a reminder again. We have our annual dinner coming up, as I mentioned, and November the 15th. So there you go. What a week, right? Thursday you're here for the lecture on the aurora, and Friday you're at the dinner, right? Everybody nod up, and yeah, right. So $42 for the tickets, and we will be selling them right at the end of the meeting here. Estella's with us. Al is definitely with us, and for the loan library, Art and Ann are kicking around. You can talk to Art about membership info and cards, and the rest of the museum is closed, as usual. And of course, we have our gathering over at Kelsey's for those that are interested. And last one, I think we have XXX attendance. That's awesome.
115.
Awesome. No, I like XXX better.
115.
115? Okay, 150. I'll go with that. 115. Thanks to everybody that participated and brought material in for us and prepared presentations, spending your time. We appreciate it. Good series of talks and great images. Keep them coming in, especially while we do have some weather happening. And again, thanks to our host here at the Canada Science and Technology Museum. Complaints? Talk to me. Want to be a meeting chair? Talk to me. Come talk to me. I'm actually talking to a bunch of people, but I don't know if all of you certainly, and if there is anybody that's interested in perhaps coming up here and making a total idiot of, coming up here and running our meetings there, please come and talk to me. Actually, it's a lot of fun. And our next meeting will be November the 1st at 8 o'clock. Yeah, that's actually, that's only about 4 weeks away. That's great. Okay, and do we have anything else? No, we're good. We're good. So, and again, any observations, any ideas, any talks that you think you'd like to share with the rest of the audience, please come and talk to us. Also, again, for those that may not have heard, if you've got things collecting dust on your shelf, they don't have to be books. They can be posters, eyepieces, telescopes, semi-precious stones, anything like that you want to give away. Yeah, we need door prizes. We always need door prizes. All things are welcome. Thank you very much for coming. I wish you clear skies, and we will see you all next month. Take care.